Hello, grade 11s. So continuing with this exercise 7.12, going on to number 2, GIKL. All right, so having a look at question G, we've got 1 minus 3 cos squared x equals sine x, where x is an element, minus 180 up to 180. Okay, this is very similar to another one that we've done previously. What I'm going to do is I'm going to change the cos squared into 1 minus sine squared. Then we've got this whole equation in terms of one trig function. So we're going to use our square identity where cos squared alpha is equal to 1 minus sine squared alpha. All right, so we get here 1 minus 3, 1 minus sine squared x is equal to sine squared x. Distribute the minus 3 in and then take the sine x to the other side, and we get 1 minus 3 plus 3 sine squared x minus sine x equals 0. Just arrange from highest powers to lowest powers and get like terms together, and we get 3 sine squared x minus sine x minus 2 equals 0. Okay, I'm going to use my little substitution. You remember I make x as causes x and sines y. So we have here 3y squared minus y minus 2, because I'm making the signs y. I can now factorize this, and we get 3y plus 2, y minus 1. Back substitute, 3 sine x plus 2 sine x minus 1 equals 0. So we have something times something equals to 0. I'm going to set them both equal to 0 and solve. And for this one here, we will get sine x is equal to minus 2 over 3, or sine x equals 1. All right, I'm going to break this down into two parts, grade 11s, because you know these sine general solutions have two parts to them, okay? So I'm going to make this one 1 and this one 2, and I'm going to treat them separately. If we look at number 1, the general solution for this one, if we go shift sine minus 2 over 3, we'll get a general a reference angle of negative 41.8. So we'll get x is equal to negative 41.8 plus k360, or x is equal to 180 minus 41.8 plus k360. I'm just going to simplify this, and we get x is equal to 221.8 plus k360, where k is an element of the integers. All right, I'm going to solve for this by substituting my k values, and then I'll do the same for this number 2, and then I'll join both solutions at the end, okay? So I'm going to here make k is equal to 0 and see what we get. If I make k is equal to 0 for this one here, we'll get that x is equal to negative 41.8. And then for this one here, we'll get x is equal to 221.8 degrees. I come back to my interval. We can see that negative 41.8 lies in this interval, so that one we can have. This 221.8 is outside, so we can't have that one. I'm now going to have a look. If I make k 1, we can see that we're going to be bigger than 180 for this one. And if I make k 1 here, we're definitely going to be bigger than my 180. So there's no point in going when k is 1. If I make k minus 1, this one could work, and this one could work. So let's just test when k is equal to minus 1. So if k is minus 1 for this one, we're going to get x is equal to negative 401.8 degrees. And then when k is minus 1 for this one here, we'll get x is equal to negative 138.2. Right, this one is definitely out because it only goes up to minus 180. This one does lie within there, so that is a solution. Now, grade 11 says no point going k is equal to minus 2. It's going to be too big. We're going to be outside our interval there. So I'm going to leave that one for now. Now I'm going to go for number 2. And our general solution for number 2, we just go shift sine 1 to get our reference angle. And we get that x is equal to 19 plus k360. Or x is equal to 180 minus 90 plus k360. So here x is equal to 90 plus k360. And you can see they're both the same. All right. So let's test when k is equal to 0. When k is equal to 0, x is equal to 90. Now when k is equal to 1, you can see it's going to be bigger than 180. And then when k is minus 1, it's going to be less than minus 180. So there's no point in going for those. And this is in our interval. So now I'm ready to write up the solution. So x is an element. Now remember, go from smallest to biggest. So our smallest is this minus 138.2. The next one would be negative 41.8. Then the next one would be this 90. And there's our solution for that. Okay, I'm going on to question I. Question I is asking, two plus sine squared x equals 5 sine x cos x, where x is an element from 0 up to 720. Okay, grade 11s, this is a little bit of a tricky one because I can't use that square identity thing that I've used before and change it to 1 minus cos squared. Because you see here, we've got a combination of sine and cos. So I can see I'm going to get like a trinomial that has a combination of x, y. So what I'm going to do is I'm going to be sneaky here. And I'm going to say that this here is 2 times 1. If I do that, I know that cos squared alpha plus sine squared alpha is equal to 1. And I can introduce a cos squared and a sine squared. Then I have a trinomial in terms of sine and cos, or x and y. So that's what I'm going to do there. And you can do that with any constant or anything. You can say it's 1 times that. Okay, and then introduce your square identity. So over here, I'm going to get 2 times sine squared x plus cos squared x plus sine squared x. And I'm just going to take this to this side, minus 5 sine x cos x equals to 0. Distribute my 2 in, and we get 2 sine squared x plus 2 cos squared x plus sine squared x minus 5 sine x cos x equals to 0. I'm going to arrange it from sine to cos, all right? So that and that will give us 3 sine squared x. And you're probably asking, why am I doing the sine first? Because if I look at my middle term, this thing here, that'll be our middle term. I can see the sine is first and then the cos is second. So that's what I'm going to do here. Make my sine squared first, my cos squared last. Okay. Our middle term is going to be this minus 5 sine x cos x. And then our last term is just going to be this plus 2 cos squared equals 0. Now, if I do my little substitution thing, sines become y, coses become x. We are going to get 3y squared minus 5yx plus 2x squared. And if we factorize that, we're going to get 3y minus 2x and then y minus x. Okay, back substitute, making y sine and x's cos. And we get 3 sine x minus 2 cos x, sine x minus cos x equals 0. We have something times something equals 0. Set both of them equal to 0, and then we can solve. So this one here, we'll get 3 sine x is equal to 2 cos x, or sine x is equal to cos x. All right, so what I'm going to do here is, this is like a previous example that we've done. I'm going to divide both sides by cos, because then we have sine over cos, which gives us tan. I'm also going to divide by 3 to get the 3 on that side. So what we'll get here is we'll get, so I'm going to divide by cos, and those will cancel. So sine over cos is tan x equals, then divide by the 3, so we get 2 over 3. Okay. Likewise here, divide both sides by cos x. So sine over cos is tan x equals cos over cos is 1. All right, do the general solution for your tan. So just go shift tan 2 over 3, and you'll get that x is equal to 33.7 plus K180. And then for this one over here, shift tan 1, and you will get x is equal to 45 degrees plus K180. All right, so let's choose our values for k. So when k is equal to 0, we can see we're going to get here x is equal to 33.7, and here we'll get x is equal to 45. Those are both within our interval there. Now, grade 11s, you can see there's no sense in going when k is equal to the negatives, because then we're going to be going less than 0. Our interval doesn't go to the negatives. It's only between 0 and 720. So when k is equal to 1, we get 37.7 plus 180, and we get x is equal to 213.7 degrees. And then for this one, we get 45 plus 180, and we get x is equal to 225. Those are both within our interval, so we can have that one and that one. Go when k is equal to 2. So when k is equal to 2, we've got 37.7 plus 360. And we get x is equal to 393.7. And for this one, we get 45 plus 360 gives us 405. These are both within our interval. When k is equal to 3, we get x is equal to 37.7 plus 3 times 180, and we get 573.7, and x is equal to 45 plus 3 times 180, and we get 585 degrees. Those are both within our interval. Now, grade 11, so I'm not going to go when k is equal to 4, because I can see it's going to be well without our interval there. So we can write up our solution here. X is an element, starting from the smallest to the biggest. We've got 33.7, 45, 213.7, 225, 393.7, 405, 573.7. And the last one, 585. Okay, and that's our solution. Right, moving on to the next one. Which is question K. Right, question K is asking us sine 2x equals cos x minus 60, where x is an element minus 180 up to 180. All right, so we can't do our little trick here where we divide both sides by cos and get a tan because our angles are different. But what I can do is I can change the cos to a sine by using 90 minus. So I'm going to say 90 minus x minus 60. And remember, as soon as I do that 90 minus, that cos will change to a sine. So we get sine 2x is equal to sine 90 minus x minus 60. I'm just going to simplify that, and we get sine 2x is equal to sine 90 minus minus 60 is 150. And then the minus times the x will give us minus x. Okay, now because we've got a sine is equal to a sine, that will be our angle, that will be our reference angle. So we can use our sine general solution now, and we get 2x is equal to 150 minus x plus k360, or 2x is equal to 180 minus 150 minus x plus k360. All right, let's solve for x over here. I take that to that side, it becomes a plus, so we get 3x is equal to 150 plus k360. Divide 3 by the 3, and we get x is equal to 50 plus divide that by 3, and we get k120. All right, let's do the same for this one. That's going to give us 2x equals 180 minus 150 gives us 30. Then that will give us plus x plus k360. Take that x to that side, becomes a minus, and we get x is equal to 30 degrees plus k360. All right, where k is an element of the integers. All right, let's choose values for k now. So when k is equal to 0, we get x is equal to 50, x is equal to 30. Those both lie within our interval, so we can have those as solutions. I'm going to now test when k is equal to 1. So over here we'll get 50 plus 120, and we get 170. X is equal to, here we'll get 30 plus 360, which gives us 390. All right, so that's within our interval, and that's out our interval. There's no point in going k is equal to 2 grade 11, so you can see it's going to be well without our interval. Okay, so now I'm going to test k is equal to minus 1. So here we get 50 minus 120, and we get x is equal to minus 70. And here we get x is equal to minus 330 degrees. Right, that is within our interval, that is outside. No point going into k is equal to minus 2, it'll be outside our interval. X is an element, list from smallest to biggest. So our smallest is minus 70, next is 30, 50, and the last one, 170. All right, last question, grade 11s, question L. Question L is asking sine x equals 3 cos x, where x is an element from 90 up to 360. Right, a nice easy one. I'm going to divide both sides by cos. So sine x over cos x gives us tan x equals, those will cancel and we're left with 3. We can use the tan general solution now. So you just go shift tan 3 and we will get x is equal to 71.6 plus k180, where k is an element of the integers. All right, so let's go for our solutions now. When k is 0, we will get x is equal to 71.6 degrees. That is in our interval. Right, if we choose k is equal to -1, we can see we're going to be well below that. So there's no point going in for the minuses. I'm just going to test maybe for the +1. Maybe we in our interval here, maybe not. Let's have a look, see. So, oh, this is not in our interval. Sorry, grade 11s. Because we need to be more than 90. My bad. So when k is equal to 1, we get x is equal to 71.6 plus 180, and we get 251.6. That is in our interval. All right, that is in our interval. No point going in when k is equal to 2. I can see it's going to be outside. So here we only have one solution. X is equal to 251.6 degrees. Okay, thanks, grade 11s.